Morse test working. Purpose and principle of the Morse test. The Morse test is performed on multi-cylinder engines to determine indicated power, IP, of each cylinder by measuring the loss of brake power, BP, when individual cylinders are successively cut off. The working principle is simple. When a cylinder is disabled, its contribution to total power drops, and this decrease is used to calculate the cylinder's indicated power. The test assumes that friction power remains constant during cylinder cutoff. Thus, by measuring how much the brake power falls with each cylinder disabled, the relative performance and efficiency of each cylinder can be identified. Preparing the engine for the Morse test. Before conducting the Morse test, the engine is allowed to run at a constant speed and full load to achieve stable operating conditions. All operating parameters like fuel supply, cooling system, and lubrication are checked. The engine is connected to a dynamometer, which measures the brake power produced. The initial brake power is recorded with all cylinders firing. It is essential that the test is carried out at steady speed because speed variation affects torque, fuel flow, and frictional losses, which can disturb the accuracy of indicated power calculations. Cutting off individual cylinders. The actual Morse test begins by cutting off one cylinder at a time. This is typically done by disconnecting the spark plug in petrol engines or stopping fuel supply in diesel engines. When one cylinder is disabled, the engine continues to run using the remaining cylinders, but the brake power drops because the disabled cylinder no longer contributes power. This reduction in brake power is carefully measured on the dynamometer. The process is repeated for each cylinder individually, and every drop in brake power is recorded separately. Calculating indicated power of each cylinder. Once the brake power drop for each cylinder is known, the indicated power of that cylinder is calculated. The formula used is indicated power of cylinder equal drop in brake power when that cylinder is cut off. This works because the decrease in brake power corresponds to the power that the disabled cylinder was producing earlier. By performing this procedure for all cylinders, the indicated power of each one can be computed. These values help identify weak cylinders, irregular combustion, worn piston rings, poor compression, or injector and valve issues that affect power production. Total indicated power and friction power. After calculating the indicated power of all cylinders individually, they are added together to obtain the total indicated power of the engine. The friction power, FP, can then be determined by subtracting the originally measured brake power from the total indicated power. Friction power equal total indicated power minus brake power. The Morse test therefore provides valuable insights into combustion efficiency, power imbalance, and frictional losses inside the engine. It is widely used in performance testing, troubleshooting, tuning, and research to ensure that each cylinder operates at its peak potential and that engine components remain in good mechanical condition.